have done so far. We have solved exponential equations where we could get a common base. But sometimes a common base is not an option. So in this section, we're going to be using two properties. And I put those at the top of the page so we can look back and reference them whenever needed. The first one says that if you have an equation, it's legal to add a log to each side. Now technically you could add the log of whatever base you wanted. Typically we like to do log base 10 because we have that button on our calculator. Another option would be the natural log because we also have that one on the calculator, so we'll typically go with one of those two. The second property, which we won't use for a while, says that if you have a log on each side, you can take it away. Okay, so it works both directions. So when we can't get a common base, we will use this property to solve an exponential. So we're going to start with just a couple examples of how this works. So the first one, I have 8 to the x equals 21. So before, we would have solved this by getting a common base. But with 8 and 21, they do not have a common base. So we can't write them both as power of some number. So what we will do instead is add a log on each side.
So would you get the... I'll just wait till you...
Then I can use my properties to help simplify this. If you have an exponent, where can you put that? Down in front. Okay, so then if I want to get x by itself, divide. So x is log 21 divided by log 8.
Could we just put log and then put 21 over 8?
It will not be the same.
If I don't brains, it can be the same until you type it in and calculate.
So let's practice. A lot of times, well, pretty much all the time, I'm going to go ahead and give a decimal at the end of this. So we'll just make sure that everybody knows how to put these in your calculator. Really, the biggest issue is parentheses. When you type this in, every time you push a log button, it opens parentheses, so we have to close it. So we have log 21, then close that parenthesis, divided by log 8. And I get 1.464. Let's look at the next one. Still check on these to see if you can get a common base, because if you can, that's going to be usually a faster route to get to the answer. But if you don't catch it, this log thing will always work. So you're not going to be wrong if you solve it by logs. You'll get the same thing in the end. So if I have a 3 and 1.4, there's no common base there. So we start by adding a log to each side.
What are the examples of this?
What?
Like 2?
Oh, is it too close to the equation? I get what you're saying. So then properties of logs, the exponent comes down in front, which is the 2x. So if I want to get x by itself, what do we have to divide by this time? You can do it all in one step if you want.
I was just about to ask that. Do we have to do it all separate?
No, you can, but we can just easily do it at once. The only thing you need to watch your parentheses when you plug this in. So when you do the log of 1.4, it'll open a parenthesis, you have to close it. You're also going to need to put a parenthesis around the entire denominator.
Do the pick.
Mm-hmm.
So we're going to get rid of X.
Yeah, we're trying to like basically keep the x, so we moved everything else, divide it all over.
I definitely get that. But 0.153.
No, I think it's just.
I've always been just going to get a diagram of it. You're not going yet. She's not.
Okay. So our goal is to keep things as simple as possible. So sometimes we need to simplify before we add the log. We want that exponential part to be by itself. So if I'm looking at this, I could add a log from the very beginning, but I would rather not because I've got several things over here on the left. However, if they have the same base, we could combine them. What would you do with those exponents? Add. So x plus 1 plus 3x would be 4x plus 1. Okay. So we can do this just the same as we have been.
Is the E what's in the other one?
Yes. So it's like that natural log one. So you can add your regular log and do it just the same as the other problem. But if you have an E, if you add a natural log, it's going to save you a little bit of work. But like I said, if you don't think of it, it's not a big deal. You'll just keep solving it like normal.
Well, I never know the difference between like that and like just when you throw a random E.
I will never use E as just a regular variable. Whenever I use this, it is that button on your calculator. The reason this is so nice is because the natural log of E and then e to that power, remember we had a property that said if the base of the log and the exponential were the same, they could really just cancel. So anytime you have a natural log of an e, you can just cancel that out. Now that being said, if you don't think about it, it's fine. You can keep it, bring down your exponent, do it like the other one. We're going to plug it in our calculator. Your calculator will fix it, okay? You'll get the same answer. But if you catch it, it saves you a little time.
So what's the point of writing it if it just cancels out?
I was just showing you why it canceled.
So we don't have to write it?
You wouldn't have to put it
Like,
over
could we
here.
just bring it down?
If you just went from here and said that means 4x plus 1 equals the natural log of 4, that's also fine.
Okay.
So then to get x by itself, we subtract 1 and divide by 4. So when you type in the natural log, you have to close your parenthesis. And you do that whole thing divided by 4.
Hold on, why'd you put a parentheses in front of the L and the natural log or whatever it is?
Just because I want this whole thing on top. Or if you just hit natural log of 4 minus 1, enter, and then that divided by 4, enter again.
Wait.
Enter minus 1. And then divided by 4. Wait,
Mhm.
0.096.
Yep.
Okay.
How many? Yes. Are we doing this one after today?
Mhm.
Just click. Let me see what you did earlier. See if you got it. Just not my actual name.
Are there questions here?
Yeah, actually.
Okay.
What if you put a natural log of 3/4? Because technically, unless is it log 4 and then that answer might. Okay.
Yeah.
See, I started out doing it as
Oh.
natural log of 3/4.
Gotcha. No, this
No. Okay.
log of 4 is one
It's-
thing, so
okay.
you do that, then subtract
So
one.
we're just saying
Okay.
cancel.
No, because it's attached to the log.
If the one was a 4 and would.
Yeah, then you could reduce.
So then your answer, you would just.
So pretty much, if you have a natural log, you need some parentheses around it.
Yeah, basically anytime we have a log, you just do parentheses around whatever.
Got it.
Okay, let's try another one like that.
And add 2
Add our 2 over.
divided by 3.
Because we're trying to get that e by itself, so we divide by 3. Okay, so then, what do we do?
Add the thing.
Come on, am I dumb? Yeah, yeah, that's a 2, not a 3.
So we add a log on each side. Again, I used ln because I have an e in my problem. That's really the only time I use it, but either one will work. The nice thing here is when you have a natural log and an e, they will always just cancel each other out. So we have,
I'm sorry, I did not get that part at all.
okay. So, here, let me just do this. If you didn't cancel them, okay, then.
No, I don't get why you cancel them.
Okay, so an ln is the same thing as log base e of e. So if you were trying to figure out what that equals, it'd be like saying e to the x power equals e. So that's just a 1, so it's x equals 1. So basically whenever you have log base e of e, it simplifies into a 1. If you don't catch that, you can still just bring down the 5x and keep that log and get x by itself. You would have to divide by the 5 and the natural log of e and you'll get the same answer. So if you don't cancel them, it's not a big deal. You're going to get to the same point. So if I type in that one.
Yeah, can we only do the front page today?
I thought we should do all notes today and not math, so.
So we should get 0.16. Nice.
I feel it's wrong just putting decimals. I'm sorry, us juniors shouldn't be doing
What?
that either.
That's what I'm saying.
Yeah, they're not gonna come out pretty. Only the problems where you could have got a common base, well, they turn out nice. The rest of them will.
They probably didn't get let out early, they probably ran out early.
I don't think they
Okay. So we're going to try a few more. So if I'm trying to get my exponential by itself here, divide the 5. I don't care if you write this as 6 divided by 5 or you want to write it as a 1.2. It doesn't matter. Then we have to add the log. You can do regular log or natural log. They work the same way. It's just whichever button you want to push on your calculator, really. So properties of logs, this exponent comes down.
those to 3.
Pretty much, yeah. Point
Yeah, I
one
feel like
six
it's-
59, so 0.166.
I feel like it's gonna get way harder than this.
Me too. Trying to throw in a bunch of other numbers. Next time, well, for the next year's class, the little colon thingies, you should make them like the,
Yeah, I need to add some spaces, I think, between the example and the problem. That would help. I'm noticing that on the ones I have up here too. Sorry about that.
I just.
I'll make changes.
No, it's fine, I literally was just, like, when I.
But
first
it does, like looking at this, it does kind of run
When
together.
I first looked.
Just
at
a
it, I
little
was
extra
like,
space there would help.
It's pretty, especially the 5-5 one.
Mm-hmm.
Yeah.
What? I mean.
It looked like ratios into like, yeah, well,
Okay.
Do you add the 5 and
I was
then
about to
divide?
say, add the 5
Yeah.
divided by 4.
Yep. Add our 5 over. So we still can't get a common base. So the x plus 3 has to come down. I'm going to write it in parentheses because we're putting our log on each side. Okay, so then if I'm trying to get x by itself, we could divide the log 2 over.
You need to subtract right outside.
Mm-hmm. So log 20 divided by log 2 with a minus 3 on the end.
Wait, so would you have to put like both of the logs in like a parentheses?
You can, but you actually won't have to, since they don't have any other terms with them. So we hit 1.3219. Questions? There. I'm going to do 7 and 8, and then I'm going to stop for 2. Okay. So these, I just need you to stick with me. They're a little bit longer because we have multiple x's in them. But the process is the same. So when I'm looking at this, I have more than one exponential. When we have more than one, we have to make sure we can get all of our x's on one side. So I'm going to start just by adding my log. And then once we add the log, exponents can come down in front.
So can you just do like the log 5 and then put it on one side and then get the.
Can you
x on the
subtract
other
that whole
side?
thing?
we could divide this log 8 over, and that will kind of help us. We have to eventually get our x's on the same side. So there's different steps you can take to do it. It will probably be less ugly if we just go ahead and distribute that first. So it'd be an x log 8, the x just stays in front. 1 times log 8 is just log 8. Alright, so then from here, we can look at it and see we have more than one x, so we need those on the same side. Mhm. This is pretty ugly, but we're actually almost to the answer. Both of these have an x in them. We can pull it out. So now we have x times something. So to get x by itself, we divide.
Bro, Miss Sarah, is there problems like this on the homework?
Wait, do we just have to know some of it for now and then we're gonna learn more of it?
Yeah, we're gonna keep practicing
So
this
the-
on Monday. So it's like, no, I don't expect you to be able to.
Like these ones?
These, yeah, we're going to practice more of these.
Yeah, I need
These
to
are,
notice.
they added a lot more to it.
Like, it makes sense right now, but
It's just a lot to do in one problem, I know. And these are as long as these problems will give you, or will get. I won't give you anything uglier than this. So when we type this in, we just really have to be careful. Lots of parentheses here because every time you push a log, it closes it. And then I put a parenthesis around my entire denominator. I get 1.825.
really shouldn't care.
Yeah, but you do. Huh?
Alright, let's.
I think we should just stop there.
I'm debating. Why don't we? There's 2 problems on the Math Excel like this, but we will do some more of those on Monday.